son, it ain't even fun no more. I'm jaded, man, it's just a game. I just played to play. I put my feet in the footprints left of me. Without saying the word, the ghetto's got a mental telepathy. Man, my brother hustles so naturally. Up next is me, and what perplexes me.
Let's discuss some characteristics of sound. Sound is pressure variations that travel in the medium, and in most cases that medium is air for us humans. Because it's a wave motion, it has a certain speed, the speed of sound. And the speed of sound depends on the physical parameters of the medium, and the velocity can be expressed as such. The velocity is the radical of bulk modulus divided by the density. Now, the bulk modulus is, in essence, the ability of the substance to resist compression. Let's put it out here. Resistance to compression. If you think about rock is really hard to compress, which means that its bulk modulus is really large, much larger than that of the air, and that explains why the speed of sound in rock is much higher than in the speed of sound in air. In fact, the bulk modulus has units of Pascal, which is the units of pressure as well. It just happens to be so. The other parameter is the density of the medium, which is usually quite low for gases. Let's compare two different gases, helium and air. They both have pretty much the same bulk modulus B, but because the density of helium is less than that of the air, this results into higher velocity of sound in helium. Like any wave motion, sound obeys the following relationship for the velocity. It is the product of wavelength and frequency. In the case of sound, the frequency is a lot of times called the pitch. The audible frequency, that is the range of frequencies the humans can hear, spans from about 20 Hertz to 20,000 Hertz. And this here is called the audible range of sound. If we have frequencies that are higher than that on this side, these are called the ultrasound frequencies. A lot of animals are capable of communicating in that frequency range. And below the audible range, on this side, we have the infrasounds, or infrasound. Just to finish this off, let's consider the speed of sound in air. It follows approximately the following expression: 331 meters per second plus 0 times 6 times T, where T is the temperature of the air expressed in Celsius. This temperature dependence comes from the fact that the density of air depends on the temperature. So if we have air at the room temperature, which is 20 Celsius, the speed of sound is about 343 meters per second.
Cause I be doing the most.
I grew up a fucking screw up, got introduced to the game.